The rain hammered against the workshop windows in Springfield, Massachusetts, creating a rhythm that matched the methodical strikes of Samuel Hendrix's hammer against heated steel. It was November 1942, and while the world burned in conflict, Samuel worked in relative obscurity, surrounded by the smell of gun oil and metal shavings. At 47 years old, his hands bore the scars of 3 decades crafting firearms, each callous, a testament to his dedication to a craft that most considered outdated in the age of mass production. Samuel had spent his entire adult life in this workshop, inherited from his father, who had inherited it from his father before him. The Hendrix family had been making rifles since before the Civil War, and Samuel took immense pride in continuing that legacy. But lately, that pride had become a burden. The world had changed. Factories now churned out thousands of standardized weapons, while craftsmen like Samuel struggled to remain relevant. The door burst open, letting in a gust of cold November wind and 3 men in military uniforms. Samuel recognized the lead officer immediately, Captain Robert Morrison, a procurement officer he had dealt with before. The captain's face wore an expression somewhere between skepticism and obligation. If you're enjoying this story, please take a moment to like this video and subscribe to our channel. It helps us bring you more compelling historical narratives like this one. Captain Morrison removed his cap, water dripping from its brim onto Samuel's wooden floor. Behind him stood 2 younger officers, their faces betraying their youth despite their attempts at military bearing. One couldn't have been more than 22, his uniform still crisp and new. "Samuel," the captain began, his voice carrying the weariness of a man who had delivered too many rejections. "I'll get straight to the point. The War Department received your proposal for a new rifle design. I'm here to tell you it's been reviewed and rejected." Samuel's hammer stopped mid-swing. He carefully placed it on his workbench, taking a moment to compose himself before turning to face the officers fully. The younger one on the left was already glancing around the workshop with barely concealed disdain, taking in the hand tools and individual workstations that seemed archaic compared to modern assembly lines. "Rejected," Samuel repeated, his voice steady despite the disappointment flooding through him. "May I ask why?" Captain Morrison shifted uncomfortably, pulling a folder from his briefcase. The typed pages inside represented months of Samuel's work, calculations, drawings, and innovations he believed could save lives. "Your design calls for a semi-automatic action that you claim can fire more accurately at longer ranges than our current M1 Garand, while weighing 3 pounds less. The engineering team says it's mechanically impossible. The tolerances you're suggesting can't be maintained in mass production, and the gas system you've designed would fail under field conditions." The younger officer on the right, a lieutenant with a nameplate reading Patterson, spoke up with the confidence of someone who had never been proven wrong. "Sir, with all due respect, we've tested dozens of designs from established manufacturers. Companies with entire engineering departments and modern facilities. What makes you think a single gunsmith working in a workshop can achieve what they cannot?" Samuel felt heat rising in his chest, but he forced himself to remain calm. "Experience, Lieutenant. 31 years of understanding how metal behaves under stress, how different alloys respond to heat and pressure, how the human body interacts with a firearm. That kind of knowledge doesn't come from a drafting table or a factory floor." Captain Morrison held up a hand to prevent the lieutenant from responding. "Samuel, nobody doubts your skill as a craftsman. Your hunting rifles are works of art. But this is war. We need weapons that can be produced quickly, maintained easily by 18-year-old kids in foxholes, and function reliably in mud, sand, and snow. Your design is too complex, too refined. It's a racing car when we need a truck. Have you looked at the accuracy data I provided?" Samuel gestured to the papers in Morrison's folder. "The test rifle I built can place 5 shots within 2 inches at 300 yards. That's 40% better than current standard issue rifles." Do you understand what that means in terms of engagement ranges and soldier survivability? The third officer, who had remained silent until now, finally spoke. His nameplate read, Collins, and unlike his companions, he seemed genuinely interested rather than dismissive. How did you achieve those tolerances in your test rifle? Samuel turned to him, grateful for the genuine question. Selective heat treating of the barrel, a modified gas piston system that reduces reciprocating mass, and a trigger mechanism that eliminates 70% of the creep in standard military triggers. The barrel harmonics are controlled through a free-floating design that most manufacturers dismiss because it requires more careful assembly. Lieutenant Collins stepped closer to examine a partially completed rifle on Samuel's workbench. The other officers exchanged glances that suggested they thought Collins was wasting his time, but the young lieutenant seemed fascinated. This gas piston, how does it differ from the M1's system? For the next 20 minutes, Samuel explained his innovations, while Collins listened intently and asked increasingly technical questions. Captain Morrison checked his watch repeatedly, and Lieutenant Patterson eventually moved to the window, clearly bored. The rain continued its assault on the glass, creating a backdrop of white noise to their conversation. Finally, Captain Morrison interrupted. "This has been enlightening, Samuel, but our decision stands. The War Department needs proven designs from established contractors. We can't gamble on experimental weapons from independent gunsmiths, no matter how talented they might be." Samuel felt his last hope crumbling. "What if I could prove it works? Give me 3 months and enough raw materials to build 5 rifles. Let me demonstrate that the design is both practical and reproducible." Patterson laughed, actually laughed, the sound sharp and cruel in the confined space. "5 rifles, sir. Factories are producing thousands per day. This is exactly what I'm talking about. He's thinking like an artisan, not like someone who understands modern warfare." Captain Morrison's expression suggested he agreed, but was too polite to say so directly. "Samuel, the answer is no. Focus on what you do best. The military has contracted with Springfield Armory, Winchester, and other major manufacturers. That's where our weapons will come from. I'm sorry for wasting your time." The 3 officers moved toward the door, but Lieutenant Collins hesitated, looking back at Samuel with something that might have been sympathy or perhaps recognition of wasted potential. Outside, the rain had intensified, turning the street into a river of mud and fallen leaves. After they left, Samuel stood in his workshop, surrounded by the tools of his trade and the weight of his failure. The test rifle sat on his workbench, a testament to months of late nights and innovative thinking that had just been dismissed as impossible. He picked it up, feeling its perfect balance, knowing that every component had been crafted to exact specifications that he carried not in blueprints, but in the muscle memory of his hands. The following weeks were difficult. Samuel tried to return to his regular work, filling orders for hunting rifles and repairing firearms for local customers, but the rejection gnawed at him. Every newspaper he read carried stories of battles in North Africa and the Pacific, of American soldiers engaging enemy forces at distances where accuracy meant the difference between life and death. He couldn't stop thinking about how his rifle could change those outcomes. His daughter, Margaret, visited on a cold Sunday in early December. At 23, she had inherited her father's analytical mind, but had channeled it into mathematics, working as a computer at a nearby defense contractor, calculating ballistic trajectories for artillery shells. She found Samuel in his workshop, as always, but noticed immediately that something was wrong. "Dad, you haven't touched your coffee." In the 10 years since her mother had passed, Margaret had learned to read her father's moods through small details. The cold coffee was one sign. The fact that he was resharpening tools that didn't need sharpening was another. Samuel looked up from the grinding wheel, switching it off. The silence that followed felt heavy. They rejected the rifle design. Margaret pulled up a stool, her practical wool coat still buttoned against the workshop's inadequate heating. "Tell me what happened." As Samuel recounted the meeting with Captain Morrison and the other officers, Margaret listened with the focused attention she brought to complex mathematical problems. When he finished, she was quiet for a long moment, her fingers drumming a pattern on the workbench that Samuel recognized as her thinking rhythm. The lieutenant who was interested, Collins. "Do you remember his first name?" she finally asked. "Thomas, I think." "Why?" Margaret stood, moving to examine the test rifle Samuel had built. She picked it up with the careful respect her father had taught her since childhood, checking the chamber before shouldering it and sighting along the barrel. What if the problem isn't the design, but who's presenting it? You're asking the military to trust an individual craftsman over major corporations. That's not a technical decision, it's a political one. Samuel felt a flicker of something he was afraid to identify as hope. "What are you suggesting?" "I'm suggesting that you need an advocate inside the system, someone who understands both the technical merits and the institutional politics." She set the rifle down carefully. "One of my colleagues, her brother works in the Ordnance Department in Washington. If I could get your detailed specifications to the right person, someone who could understand what you've achieved, maybe there's another path forward." "Margaret, they've already decided." Captain Morrison was clear. They decided based on a 15-minute conversation and prejudgment about small workshops versus factories. But what if someone actually tested your rifle properly? What if the data proved your claims? She moved to the filing cabinet where Samuel kept his technical drawings. "How many of these complete specification sets do you have?" "3. But what good will they do?" "The decision has been made." Margaret pulled out one of the sets, spreading the detailed drawings across the workbench. "In mathematics, we learned that the first solution to a problem is rarely the only solution. You approached this through official channels and got rejected. So we find an unofficial channel, someone who cares more about saving soldiers' lives than about following procurement protocols." Over the following weeks, Margaret worked her network of contacts, which proved surprisingly extensive for someone her age. The defense industry in 1942 was interconnected in ways that surprised Samuel. Engineers, mathematicians, and procurement officers all knew each other through various projects and facilities. Margaret's colleague did indeed have a brother in the Ordnance Department, a Major William Chen, who specialized in small arms evaluation. Getting the specifications to Major Chen was one thing, getting him interested enough to actually review them was another. But Margaret had included something with the technical drawings, a series of photographs showing the test rifle alongside target sheets documenting its accuracy, plus a detailed cost analysis that Samuel had prepared, showing how his design could actually be produced more cheaply than current rifles, despite its enhanced performance, if manufactured with modern equipment, but his refinements. In late January 1943, Samuel received a letter. Not an official War Department communication, but a personal letter from Major Chen. The Major would be in Massachusetts in 2 weeks for inspections at Springfield Armory. He wanted to see Samuel's rifle and workshop, unofficially, on a Sunday when he had personal time. The day Major Chen arrived, Samuel had prepared everything he could think of. The test rifle was cleaned and ready, along with 2 partially completed rifles that demonstrated the manufacturing process. He had prepared documentation, test results, and explanations for every aspect of his design. What he wasn't prepared for was the man himself. Major William Chen was in his mid-30s, with the bearing of a career soldier, but the eyes of an engineer. He arrived in civilian clothes, driving his own car, making it clear this visit was happening outside official channels. Behind him emerged Lieutenant Thomas Collins, the young officer who had shown genuine interest during the first meeting. "Mr. Hendricks," Major Chen said, extending his hand. Lieutenant Collins suggested I see this rifle for myself before writing it off completely. I've reviewed your specifications. They're either the work of a genius or a madman. I'm here to determine which. Samuel shook his hand, noting the Major's firm grip and direct gaze. I hope you'll give me a chance to prove it's the former, sir. What followed was the most thorough technical examination Samuel had ever experienced. Major Chen didn't just look at the rifle. He disassembled it completely, examining each component with precision instruments he had brought with him. He questioned every design choice, every measurement, every material specification. Lieutenant Collins assisted, clearly having studied the drawings in advance and asking questions that demonstrated a growing understanding of what Samuel had achieved. The interrogation lasted 4 hours. Major Chen tested the trigger pull, examined the barrel with a borescope, measured chamber dimensions, and reviewed Samuel's heat-treating process. He studied the gas system with particular intensity, clearly trying to understand how Samuel had overcome the problems he claimed to have solved. Finally, as the winter afternoon faded into early evening, Major Chen reassembled the rifle and turned to Samuel. I need to see it shoot. Not here, but under controlled conditions, where we can document everything. Can you and this rifle be at Springfield Armory's test range next Saturday at 0600 hours? Samuel felt his heart racing. Yes, sir, absolutely. Major Chen's expression remained neutral. I'm making no promises, Mr. Hendricks, but I believe in data over assumptions. If your rifle performs as you claim, under conditions that I control and document, then we'll discuss next steps. If it doesn't, then this conversation ends, and you accept that your design isn't practical for military use. Agreed? Agreed, Samuel said without hesitation. The following Saturday arrived with clear skies and bitter cold. Samuel arrived at the armory range to find Major Chen had assembled a small team, 2 master gunsmiths from the armory, a ballistics expert, and Lieutenant Collins. There were also 3 current-issue M1 Garand rifles set up for comparison testing. The test protocol was rigorous. They would fire both Samuel's rifle and the M1s at various distances, documenting accuracy, reliability, and handling characteristics. Each rifle would fire 200 rounds under controlled conditions, then be exposed to various environmental stresses, immersion in cold water, exposure to sand and mud, rapid temperature changes, and then required to continue functioning. Samuel watched nervously as the armory gunsmiths first examined his rifle with professional skepticism. One of them, a grey-haired man named Peterson, who had been building military rifles for 25 years, was particularly thorough in his inspection. Several times he paused to re-examine something, his expression shifting from skepticism to puzzlement to what might have been grudging respect. The accuracy testing came first. At 100 yards, Samuel's rifle performed comparably to the M1. At 200 yards, a slight advantage became apparent. At 300 yards, the difference was undeniable. Samuel's rifle consistently grouped shots 40% tighter than the M1's, just as he had claimed. Major Chen recorded every measurement personally, allowing no room for dispute or error. Lieutenant Collins operated the spotting scope, calling out each impact point, while the ballistics expert plotted the data on graph paper. As the numbers accumulated, the atmosphere began to shift. The armory gunsmiths stopped whispering to each other and started paying closer attention. The reliability testing was even more critical. They submerged Samuel's rifle in a trough of ice water for 30 minutes, pulled it out, drained it quickly, and immediately attempted to fire. It functioned perfectly. They packed sand into the action, cycled it several times to work the sand into every crevice, and fired again. After a brief moment of resistance, the action cleared itself and continued functioning. Peterson, the skeptical gunsmith, finally spoke up. The tolerances should be too tight for this. How does it keep functioning with this much contamination? Samuel, who had been quiet throughout the testing, finally explained. The gas system uses slightly more pressure than necessary under ideal conditions, creating redundancy. When conditions degrade, that extra pressure ensures reliable cycling. And the trigger mechanism is sealed differently than standard designs, keeping contaminants out of critical areas. By noon, they had completed the full test protocol. Samuel's rifle had fired 240 rounds without a single malfunction, maintained superior accuracy throughout, and proven more resistant to environmental degradation than the M1 Garands tested alongside it. The data was incontrovertible. Major Chen gathered his team for a brief conference while Samuel waited, trying not to let hope overwhelm his pragmatism. The men spoke in low tones, examining the data sheets and occasionally glancing at the rifle. Finally, they broke their huddle and approached Samuel. "Mr. Hendricks," Major Chen began, his expression still professionally neutral, "your rifle performs exactly as you claimed. The question now is whether it can be manufactured at scale. I'm prepared to recommend limited production of 50 rifles for field testing with frontline units. But this requires your cooperation in ways that might be difficult for you." Samuel felt relief flooding through him, but Major Chen's tone suggested complications ahead. "What kind of cooperation?" "You'll need to work with Springfield Armory's engineers to adapt your design for mass production. This means compromising some of your hand-fitted tolerances in favor of parts that can be made on standard equipment. It means accepting that factory-built versions won't be quite as refined as your handmade prototype." "Can you accept that?" Samuel looked at his rifle, the product of countless hours and 3 decades of accumulated knowledge. Every component was perfect, adjusted to tolerances that existed in his hands rather than on any blueprint. The thought of compromising that perfection hurt, but then he thought about the target sheets showing the rifle's superior accuracy and what that could mean for soldiers in combat. If it means getting these rifles to soldiers who need them, yes, I can accept that. The collaboration that followed tested Samuel in ways he hadn't anticipated. Working with Springfield Armory's engineers meant explaining techniques he had developed through intuition and experience, translating hands-on knowledge into specifications that could be replicated by others. It meant watching as they simplified some of his more elegant solutions in favor of manufacturability. It meant accepting that good enough was sometimes better than perfect if it meant production could happen faster. The first week at the armory was disorienting. Samuel arrived each morning at 7, entering a facility that employed over 3,000 workers. The scale was overwhelming compared to his solitary workshop. The noise alone, stamping presses, grinding wheels, testing ranges, created a constant industrial symphony that made concentration difficult. Workers moved with practiced efficiency through assembly lines where hundreds of rifles took shape simultaneously, a stark contrast to Samuel's careful, individual craftsmanship. Major Chen had assigned Samuel a small office adjacent to the engineering department. The space was sterile and functional, a metal desk, filing cabinets, fluorescent lighting that gave everything a harsh, flat appearance. Samuel felt claustrophobic there, missing the natural light and familiar tools of his workshop. But he understood this was necessary, that collaboration required proximity to the people who would translate his designs into mass production. The engineering department itself was a revelation. Dozens of draftsmen worked at tilted desks, creating detailed technical drawings with mechanical precision. Their work was meticulous, every line exact, every dimension specified to thousandths of an inch. Samuel watched them transform his hand-drawn sketches into formal blueprints, adding manufacturing notes and tolerances that would guide factory workers who had never met him and never would. The lead engineer assigned to work with him was a woman named Dorothy Williams, one of the first female mechanical engineers hired by the armory. She was 32, brilliant, and initially as skeptical of Samuel as everyone else had been. Their first meeting in a conference room at the armory was tense. Samuel had arrived early, spreading out his original drawings and some sample components he had brought from his workshop. He arranged them carefully on the long conference table, trying to create a logical presentation. When Dorothy entered, accompanied by two junior engineers, she immediately moved to the table and began examining his work without greeting or introduction. She picked up the trigger assembly Samuel had crafted, turning it over in her hands with the careful attention of someone who understood mechanical systems. Her fingers traced the sear engagement, the spring tension points, the polished bearing surfaces. After nearly 2 minutes of silent examination, she finally looked up at Samuel. "This is hand-fitted," she stated, not as a question, but as an observation that carried implicit criticism. "Every component is individually adjusted to precise tolerances. Mr. Hendricks, do you understand what happens when we try to replicate this level of precision across thousands of units?" Samuel met her gaze steadily. "I understand that factory tolerances are looser than what I can achieve by hand, but I also understand that some tolerances matter more than others. The trigger sear engagement, for example, is critical, the exterior finish less so." Dorothy set down the trigger assembly and gestured to her junior engineers. They pulled out rolled blueprints and spread them across the table, securing the corners with paperweights. These were manufacturing drawings, showing Samuel's rifle broken down into individual components with detailed specifications for each part. "We've analyzed your design," Dorothy continued. 17 components require precision beyond our standard manufacturing capabilities. Another 23 use non-standard materials or heat treatments. The barrel alone presents 6 distinct challenges for mass production. She paused, letting the magnitude of the problem settle. "Your prototype is brilliant, Mr. Hendricks, but it's essentially a work of art. We need to transform it into something that can be built by semi-skilled workers using standard equipment and existing supply chains." One of the junior engineers, a young man named Robert Chen, spoke up hesitantly. "So no disrespect intended, but have you ever worked in a production environment? Do you understand the constraints we're operating under?" Samuel felt defensive irritation rising but forced it down. He thought about Captain Morrison's initial rejection, about Lieutenant Patterson's dismissive laughter. Getting angry would only confirm their prejudices about stubborn craftsmen who couldn't adapt to modern methods. "No," he admitted, "I've never worked in a factory setting. My entire career has been individual craftsmanship, but I do understand constraints. Every gunsmith works within constraints. Available materials, customer budgets, time limitations. The constraints are different at scale, but the fundamental challenge is the same: achieving the best possible result within realistic limitations." Dorothy's expression softened slightly, perhaps recognizing Samuel's willingness to acknowledge his limitations. "Then let's start with education. Before we can collaborate effectively, you need to understand our world, and we need to understand yours. I'm proposing we spend this first week simply learning from each other." What followed was an intensive mutual education that challenged both Samuel's assumptions and the engineer's preconceptions. Dorothy arranged for Samuel to tour the entire armory operation, from raw material receiving through final inspection. He watched as steel bars were transformed through progressive stages into rifle barrels, the process broken down into discrete operations that different workers repeated hundreds of times daily. At the barrel-making station, Samuel observed a skilled operator named Frank Martinez, who'd been forming barrels for 12 years. Frank worked with smooth efficiency, loading blanks into a massive rifling machine that cut spiral grooves with hydraulic precision. Each barrel took 23 minutes to complete, and Frank typically processed 18 barrels per shift. Samuel introduced himself and asked if he could watch for a while. Frank, initially suspicious of this outsider from the engineering department, gradually warmed as Samuel asked informed questions that demonstrated genuine understanding of the process. "The rifling depth is controlled by this hydraulic pressure gauge," Frank explained, pointing to a large dial. "We're supposed to maintain between 2,000 and 2,200 psi. Any less and the grooves are too shallow. Any more and we risk damaging the cutter head." Samuel nodded, watching the machine work. "What's your rejection rate?" Frank's expression darkened. "About 8%. Sometimes a barrel looks perfect, but fails the pressure testing later. We think it's inconsistency in the steel quality, but purchasing says the supplier is within specifications." This conversation, repeated across multiple stations with different workers, gave Samuel crucial insights. The factory wasn't just one large operation, but dozens of smaller processes, each with its own challenges, limitations, and skilled operators trying to maintain quality under production pressure. The workers weren't mindless automatons, but craftsmen in their own right, experts in their specialized tasks. When Samuel reported back to Dorothy, he brought a different perspective than she expected. "I watched Frank Martinez make barrels for 3 hours. He's as skilled at his job as I am at mine. The problem isn't the workers or their capabilities. It's that my design assumes continuous feedback and adjustment throughout the process. Frank makes one specific cut and then never sees that barrel again. He can't adjust based on how the steel is behaving that particular day." Dorothy leaned back in her chair, surprised. That's remarkably insightful for someone who's never worked in production. "You're identifying one of our fundamental challenges: how to maintain quality when the process is fragmented across multiple specialized operations." Over the following days, Dorothy reciprocated by visiting Samuel's workshop. She brought Robert Chen and another junior engineer named Alice Foster. The 3 engineers spent an entire day watching Samuel work on a custom hunting rifle, observing his methods and asking questions about his techniques. They watched as Samuel hand-selected steel for a barrel blank, explaining how he could read the material's quality through subtle visual cues and by feeling its density. They observed his heat-treating process, where he judged temperature by color rather than relying on instruments, achieving precise results through experience and intuition. Alice Foster was particularly fascinated by Samuel's trigger work. She watched him hand-fit components with files and stones, achieving engagement surfaces so precisely matched that the trigger broke cleanly at exactly 4 pounds of pressure with no perceptible creep. "How do you measure the pressure without a gauge?" she asked. Samuel smiled slightly. "Years of practice, but also feel." He demonstrated by working the trigger several times. "Your finger is a remarkably sensitive instrument. Once you've felt thousands of triggers, you develop a sense for what 4 pounds feels like versus 4.2 pounds. Robert Chen shook his head in wonder. "We use spring scales and precision instruments to achieve what you're doing by feel. And honestly, your results are more consistent than ours. That's because I'm adjusting for each individual component," Samuel explained. "This sear is slightly softer steel than the last one I worked with, so I'm compensating by changing the engagement angle by a fraction of a degree. A factory worker following fixed specifications couldn't do that." Dorothy had been silent during much of this observation, taking notes and occasionally photographing Samuel's work with a camera she had brought. Finally, she looked up from her notepad and met Samuel's eyes. "I think I understand now what we need to do. We can't replicate your methods in a factory, but we can identify which aspects of your design are truly critical and which are refinements that, while improving performance, aren't essential. Then we design the manufacturing process to ensure the critical aspects are maintained while accepting slightly reduced performance on the refinements." Samuel felt both relief and trepidation. That makes sense in principle. The devil will be in the details. Always is, Dorothy agreed. Mr. Hendricks, Dorothy began, laying out Samuel's original drawings alongside her own manufacturing schematics. I need you to understand something. Your prototype is a masterpiece of gunsmithing, but we can't build masterpieces on an assembly line. We need to identify which of your innovations are essential and which are merely optimal. Samuel studied her schematics, seeing immediately where she had simplified his gas system, standardized his trigger components, and adjusted his barrel specifications. Every change made sense from a manufacturing perspective, but each one felt like a small betrayal of his vision. This modified gas piston, he said, pointing to her drawing, it increases reciprocating mass by 8 ounces. That will affect accuracy. By approximately 3% according to my calculations, Dorothy replied. But it can be machined on existing equipment in 1/3 the time of your design, and it uses a standard steel alloy that's already in our supply chain. Is 3% worth doubling production time and complicating logistics? The question hung in the air between them. Samuel wanted to argue that every percentage point mattered, that 3% could mean life or death. But he also understood her point. A rifle that could be built quickly was more valuable than a perfect rifle that took too long to produce. No, he finally admitted, it's not worth it. Over the following weeks, they worked through every component, debating, calculating, and compromising. Dorothy proved to be more than just an engineer. She understood the human element of firearms design. She listened when Samuel explained how soldiers would actually handle the rifle in combat, how certain features would matter under stress and exhaustion. In turn, Samuel learned to appreciate the complexities of mass production, the challenges of supply chains, and the importance of standardization. Margaret visited the armory several times, ostensibly to deliver documents, but really to check on her father. She found him one evening in late February, working late with Dorothy on trigger specifications. The two were so engrossed in their discussion that they didn't notice her approach. If we increase the sear engagement by 0.003 inches, Dorothy was saying, we maintain reliable ignition while allowing for standard grinding equipment tolerances. But the trigger pull will increase to 5.2 pounds, Samuel countered. That's too heavy for precision shooting. Margaret cleared her throat, making them both jump. Dad, it's past 8. Even engineers need to eat. Samuel looked up, surprised to see darkness outside the windows. Margaret, this is Dorothy Williams. She's helping adapt the rifle for production. Dorothy, my daughter Margaret. The two women shook hands, and Margaret noticed a shift in her father's demeanor. He seemed energized in a way she hadn't seen since before her mother's death. The workshop at home had always been his sanctuary, but it had also been his isolation. Here, collaborating with someone who shared his passion and challenged his thinking, he seemed alive in a different way. By mid-March, they had completed the modified design. 50 rifles were put into production, each one incorporating Samuel's innovations adapted for mass manufacturing. The prototype took 6 weeks to build, with Samuel and Dorothy personally overseeing every step. They trained the armory workers on the new techniques, adjusted processes when problems arose, and gradually refined the production workflow. Lieutenant Collins had been assigned as the military liaison, coordinating with frontline units for the field testing. He visited the armory regularly, watching the rifles take shape with obvious excitement. The young officer had become a genuine advocate for the project, and Samuel appreciated his enthusiasm. In early April, the first batch of 10 rifles was complete. Major Chen arranged for them to be shipped to a Marine unit preparing for operations in the Pacific. The unit's commander, Colonel James Morrison, no relation to the captain who had rejected Samuel's original proposal, was known for being willing to test new equipment if it showed promise. The waiting period was agonizing. Samuel returned to his workshop but found it difficult to focus on regular work. Every day he checked for news, for reports, for any indication of how the rifles were performing. Margaret tried to distract him with visits and conversation, but they both knew he wouldn't rest until he heard something concrete. The letter arrived in late May, hand-delivered by Lieutenant Collins. Samuel was in his workshop when the lieutenant's car pulled up. The young officer's expression was unreadable as he approached, and Samuel felt his stomach tighten with anxiety. "Mr. Hendricks," Collins said formally, then his serious expression broke into a wide grin. "Colonel Morrison's initial report came through. Your rifles are performing exceptionally in field conditions. Accuracy is as predicted, reliability is outstanding, and the Marines are fighting over who gets to carry them." Samuel felt his knees weaken slightly. "They're working? Really working?" Collins handed him the official report. "Better than working, sir. Colonel Morrison is requesting an immediate increase in production. He wants enough for his entire regiment, and other commanders in the Pacific Theater are hearing about them and putting in requests too." The report was everything Samuel had hoped for and more. The Marines praised the rifles' accuracy at extended ranges, noting that they could engage Japanese positions effectively at distances where the enemy felt safe. The lighter weight reduced fatigue during long patrols. The improved reliability meant fewer jams in the humid, sandy conditions of the Pacific Islands. Several Marines had written personal testimonials describing how the rifle's accuracy had saved their lives in specific engagements. One testimonial came from Corporal Michael O'Brien, a Marine from Boston, who had been issued one of the first rifles in April 1943. His letter was typed on military stationery, precise and detailed. "On May 17th, during operations on Rendova Island, my squad was pinned down by a Japanese machine gun position approximately 370 yards distant. Previous attempts to neutralize this position with standard-issue rifles had failed due to the extreme range. Using the new rifle, I was able to place accurate fire on the enemy position despite difficult conditions, including wind and partial concealment. 3 shots eliminated the threat, allowing my squad to advance and complete our objective. With standard equipment, we would have required artillery or air support, which was unavailable due to weather conditions. The rifle's accuracy at extended range directly enabled mission success and prevented likely casualties." Another Marine, Sergeant James Patterson, described a different scenario in his handwritten account. His writing was less formal, more emotionally raw. "I've been carrying a rifle in combat for 8 months now, and I thought I understood what these weapons could do. The new rifle changed everything. During a night defensive position on Bougainville, Japanese forces probed our perimeter repeatedly. The rifle's lighter weight meant I could maintain aim longer without fatigue, and its accuracy let me engage targets at ranges where I previously would have had to hold fire and hope they came closer. Over 6 hours, I estimate I engaged at least 15 enemy soldiers at ranges between 150 and 300 yards. With my old rifle, I might have been effective against half that many. The difference isn't just numbers, it's confidence. I knew that if I could see the target clearly enough to aim, I could hit it. That confidence changes how you fight." A third testimonial came from Lieutenant David Martinez, a platoon commander who had 4 of Samuel's rifles distributed among his men. His report was analytical, almost clinical, but the implications were profound. Standard combat doctrine suggests effective engagement range for infantry rifles is approximately 200 yards under field conditions. Enemy forces understand this and typically establish defensive positions accordingly. The enhanced accuracy of the new rifle extends our effective engagement range by approximately 100 yards, creating a tactical advantage that enemy forces have not adapted to counter. During recent operations, my platoon consistently engaged enemy positions before they could effectively return fire, resulting in favorable casualty ratios and increased mission success rates. Additionally, The rifle's reliability in adverse conditions has proven superior. During 3 weeks of continuous operations in jungle environment with constant exposure to moisture, mud and coral dust, we experienced 0 malfunctions across 4 rifles, firing approximately 3,000 rounds total. This reliability reduces combat stress and increases soldier confidence in their equipment. But it was Colonel Morrison's concluding paragraph that affected Samuel most deeply. These rifles represent a significant tactical advantage. I estimate that their superior accuracy and reliability have already prevented casualties that would have occurred with standard-issue weapons. Based on comparison with previous operations using standard rifles, I conservatively estimate that use of these 10 rifles over the past 6 weeks has prevented between 15 and 20 American casualties that likely would have occurred otherwise. Immediate expanded production is strongly recommended. If possible, I request priority allocation of all available units to my regiment. Dorothy arrived at Samuel's workshop that evening, having heard the news from Major Chen. She found Samuel sitting at his workbench, the report in his hands, tears on his weathered cheeks. "We did it," he said quietly. "It's actually helping them." Dorothy sat beside him, and for a moment they simply shared the weight of what they had accomplished. Then she pulled out her own set of papers. "Major Chen wants us to return to the armory tomorrow. They're ramping up production to 500 rifles per month. We need to train more workers and further streamline the process." Over the following months, Samuel became a fixture at Springfield Armory. He divided his time between his personal workshop and the factory floor, training workers, solving problems, and continuously refining the production process. Dorothy and he developed an efficient partnership, her engineering expertise complementing his craftsman's intuition. The rifles began flowing to units across the Pacific and eventually to Europe as well. Reports continued to arrive, each one documenting successful engagements, lives saved, missions accomplished because of superior accuracy and reliability. Samuel kept every letter, every report, filing them carefully in his workshop. In August 1943, Lieutenant Collins arrived with news that made Samuel's earlier success seem like a prelude. The Army had approved full-scale production, 10,000 rifles with potential for more. But there was a complication. "Mr. Hendricks," Collins said carefully, "this level of production requires more than Springfield Armory can handle alone. They want to contract with 3 other manufacturers to build your rifle. This means sharing all specifications, all techniques, all your innovations. They become public domain, essentially. Are you prepared for that?" Samuel thought about his family's legacy, the generations of Hendricks gunsmiths who had guarded their techniques and innovations. He thought about the proprietary knowledge he had developed over 3 decades. Then he thought about the letters from Marines and soldiers thanking him for a rifle that had kept them alive. If it saves lives, they can have everything. No restrictions, no patents, no conditions. Collins looked relieved. "That's what Major Chen hoped you'd say. But there's something else. The War Department wants you to travel to several training facilities to teach advanced marksmanship techniques specific to your rifle. It would mean leaving your workshop for extended periods." Margaret, who had accompanied Collins at his request, spoke up. "Dad, you should do it. Your regular customers can wait. This is more important." Samuel agreed, and for the next year, he traveled extensively. He visited training camps in California, Texas, North Carolina, and Georgia, teaching soldiers and Marines how to maximize the rifle's capabilities. He demonstrated shooting techniques, explained maintenance procedures, and listened to feedback from the men who would carry these rifles into combat. His first assignment was at Camp Pendleton in California, where a battalion of Marines was preparing for deployment to the Pacific. Samuel arrived in late September 1943, during a heat wave that left the training ranges shimmering with visible heat distortion. The Marines, most in their late teens or early 20s, regarded him with undisguised skepticism when he was introduced. The battalion commander, Lieutenant Colonel Richard Hayes, had gathered 200 Marines in an outdoor amphitheater for Samuel's introduction. The colonel was a combat veteran himself, recently returned from Guadalcanal, and he understood the importance of superior equipment. "Gentlemen," the colonel announced, his voice carrying authority born from combat leadership, "this is Mr. Samuel Hendricks. His rifle design is being issued to selected units throughout the Corps. He's here to teach you how to maximize its capabilities. I expect you to pay attention and learn. This weapon could save your life." Samuel stood before the assembled Marines, feeling exposed and uncomfortable. These were warriors preparing for combat, and he was a middle-aged civilian craftsman. He decided to address the disconnect directly. "I'm not a soldier," he began, "and I've never been in combat. I'm a gunsmith who's been building firearms for 30 years. I designed this rifle because I believed I could build something better than what we were currently issuing to men like you." The military agreed to test it, and Marines in combat have reported that it performs as I claimed. I'm here to teach you the specific techniques that will let you use this rifle most effectively. A hand went up in the third row. Samuel nodded toward the Marine, a lanky corporal with a sunburned face. "Sir," the corporal said, "no disrespect, but we've all qualified with the M1. What makes this rifle so different that we need special training?" "Valid question," Samuel replied. "The fundamental difference is accuracy at extended range. This rifle will consistently hit targets at 300 yards that you'd struggle to engage reliably with an M1 at 250. That extra 50 yards of effective range can be the difference between suppressing an enemy position and being suppressed by it. But that accuracy advantage only matters if you understand how to aim at those ranges and maintain the rifle properly." Over the following 3 days, Samuel worked with the Marines in intensive training sessions. He started with fundamental marksmanship, demonstrating shooting positions and breathing techniques. His own shooting, despite his age, was impressive enough to earn the Marines' respect. At 300 yards, he consistently placed shots within a 4-inch circle, performance that exceeded what most of the young Marines could achieve. "The key to long-range accuracy," Samuel explained during one session, "is understanding the rifle's ballistics and your own capabilities. This rifle shoots flatter than an M1, meaning less bullet drop at distance. But you still need to estimate range accurately and adjust your point of aim accordingly." He set up training scenarios where Marines had to estimate distances to various targets without using range-finding equipment, then engage those targets and evaluate their accuracy. The exercises revealed that distance estimation was a critical skill that many Marines lacked. Samuel worked with them patiently, teaching techniques for judging range based on target appearance, environmental cues, and comparison with known distances. One Marine, Private First Class Robert Chen from San Francisco, showed particular aptitude. Samuel noticed him staying after the formal training sessions, practicing on his own time. One evening, Samuel found Chen on the range as the sun was setting, firing carefully aimed shots at distant targets. "You're showing real dedication," Samuel observed, approaching the young Marine. Chen came to attention, but Samuel waved him back to a more relaxed posture. "My father's a machinist, sir. He taught me that good tools deserve respect and practice. This rifle is the best tool I've ever been issued. I want to know everything it can do." Samuel spent an extra hour working with Chen that evening, sharing advanced techniques that went beyond the standard curriculum. He explained how to read wind at different distances by observing grass movement and heat shimmer, how to adjust for shooting uphill or downhill, how tiny changes in shooting position could affect accuracy. "The rifle has one more advantage I haven't emphasized in the group sessions," Samuel said. "Its balance and lighter weight mean you can hold a steady aim longer before fatigue affects your accuracy. In a sustained engagement, that matters tremendously. Practice holding your aim on target for 2 minutes without firing. Build that endurance. Chen nodded seriously, absorbing every word. Other Marines had started calling him Hendricks' apprentice. But Chen didn't care about the teasing. He understood that this knowledge could keep him alive. Samuel encountered similar dedicated students at each training facility he visited. At Fort Hood in Texas, a sergeant named William Rodriguez spent every free moment practicing with the rifle, eventually achieving accuracy that exceeded Samuel's own capabilities. At Camp Lejeune in North Carolina, a young lieutenant named Thomas Bradford organized extra training sessions for his platoon, drilling them on range estimation and target engagement until they functioned with coordinated precision. But Samuel also encountered resistance and skepticism. At one facility in Georgia, an experienced gunnery sergeant named Frank Morrison, no relation to the colonel or captain, openly questioned the value of the new rifle during a training session. "With all respect, Mr. Hendricks," Morrison said, his southern accent thick and his tone skeptical, "combat isn't about making 300-yard shots at stationary targets on a sunny day. It's about putting rounds downrange fast enough to suppress the enemy while you maneuver. Your rifle might be more accurate, but it's also more complex. More things to break, more maintenance required, more training needed. In combat, simple and reliable beats complex and accurate." Samuel didn't dismiss the concern. He had heard similar arguments from military procurement officers, and he knew there was validity to them. "Sergeant Morrison, you're absolutely right that simplicity has value. But let me ask you something. If you could engage an enemy machine gun position at 300 yards instead of having to close to 200 yards to be effective, would that make your job easier or harder?" Morrison considered. "Easier, assuming the rifle actually performs at that range under combat conditions." "Fair point," Samuel acknowledged. "The only proof is combat performance. Talk to Colonel Morrison of the 2nd Marines. His unit has been using these rifles since April. Ask him whether the complexity is worth the performance advantage." This exchange led to a broader discussion with Morrison and his Marines about the trade-offs inherent in weapon design. Samuel didn't try to claim his rifle was perfect or that it solved all problems. Instead, he acknowledged its limitations while explaining why he believed the advantages outweighed the complications. The conversation shifted Morrison's perspective enough that he agreed to give the rifle a thorough evaluation. A week later, he sent Samuel a brief letter. "Mr. Hendricks, I was wrong. This rifle is worth the extra training and maintenance attention. It changes engagement dynamics in ways that matter. Thank you for taking my concerns seriously, rather than dismissing them." Samuel kept that letter, adding it to his growing collection of correspondence from soldiers and Marines. Each letter represented a changed mind, a moment when someone moved from skepticism to understanding. These small victories felt more meaningful than official recognition or military commendations. At one training facility in California, a young private from Iowa approached Samuel after a demonstration. "Sir, my dad's a machinist back home. He says people like you, the craftsmen, are becoming extinct, that everything's going to be mass-produced by people who don't really understand what they're making." Samuel cleaned his rifle as he considered the question. "Your father's partly right. The world is changing, and there's no stopping that. But knowledge doesn't disappear just because the process changes. Dorothy Williams, the engineer who helped me adapt this rifle, she understands manufacturing in ways I never could. I understand metal and mechanics in ways that come from years of hands-on work. The future isn't about one approach replacing the other. It's about combining them." By early 1944, over 15,000 of Samuel's rifles had been produced and distributed to frontline units. The reports continued to arrive, now accompanied by commendations and formal recognition. In March, Samuel received notification that he would be awarded the Medal for Merit, a civilian decoration for contributions to the war effort. The ceremony took place in Washington, a formal affair that made Samuel profoundly uncomfortable. He wore his only suit, slightly outdated and not quite fitting properly after months of irregular meals and constant activity. Major Chen and Dorothy attended, along with Lieutenant Collins, who had been promoted to captain. Margaret stood beside her father, proud and tearful. Samuel Hendricks, the official read, in recognition of exceptional service to the United States through the design and development of a rifle system that has enhanced the combat effectiveness of American forces and contributed directly to the preservation of American lives in combat operations. The medal was heavy in Samuel's hands, but what he valued more were the handshakes and words from officers who had commanded units equipped with his rifles. One general, a gruff man in his 50s, gripped Samuel's hand firmly and said simply, "My boys made it home because of you. Thank you." After the ceremony, a reception brought together various people involved in weapons development and procurement. Samuel found himself surrounded by men discussing technical specifications, production challenges, and future innovations. It was overwhelming, but also validating. He had gone from being dismissed as an irrelevant craftsman to being recognized as someone whose expertise mattered. Captain Morrison, the officer who had originally rejected Samuel's proposal, approached him during the reception. Samuel tensed slightly, but Morrison extended his hand with genuine warmth. "Mr. Hendricks, I owe you an apology. I dismissed your work based on assumptions rather than evidence. That was a failure of judgment that could have had serious consequences." Samuel shook his hand. "You were following reasonable protocols, Captain. The system worked eventually, even if it took longer than it should have." Morrison smiled wryly. "Diplomatic of you. But I've learned something from this. Innovation doesn't always come from expected sources. I'm trying to be more open-minded in my current assignment." As 1944 progressed, Samuel gradually returned to spending more time in his own workshop. The rifle production was well established, running smoothly under Dorothy's management at the armory. His role shifted from active development to occasional consultation, which suited him. He had never sought the spotlight, and the attention from the medal ceremony had left him exhausted. But the workshop felt different now. The space that had once been his isolation was now connected to something larger. Soldiers across the world carried rifles that incorporated his innovations. The knowledge he had accumulated over decades, which he had feared would die with him, had been shared, documented, and integrated into a larger body of manufacturing expertise. Margaret visited one Saturday in September, finding her father at his workbench, working on a hunting rifle for a local customer. It was the first personal commission he had accepted in over a year. She watched him work for a moment, noting how his hands moved with the same careful precision they always had, but with perhaps more confidence, less of the defensive isolation that had characterized him before. "Dad, how many soldiers do you think your rifle has helped?" she asked. Samuel paused in his filing of a trigger component. "I don't know. Tens of thousands have the rifles now. Hard to say how many specific engagements have been affected." Margaret pulled a letter from her purse. "This arrived at my office yesterday. It was forwarded through several channels. The man who wrote it didn't know how else to reach you. The letter was from a Marine sergeant named David Walsh. He described a battle on a small Pacific island, a desperate defense against a larger Japanese force. His unit's accuracy with Samuel's rifles had allowed them to hold off the attack until reinforcements arrived." The sergeant's letter was matter-of-fact about the combat details, but emotional in its gratitude. He ended with, "47 men in my unit came home from that island. Based on previous similar engagements with standard rifles, our commander estimated we would have lost about half. Your rifle made the difference. Thank you." Samuel read the letter twice, then carefully folded it and added it to the collection he kept in a drawer. Letters like this had become more common as word spread about how to contact him. Each one represented lives that continued, families that remained intact, futures that were still possible. The war continued into 1945, and Samuel's rifles continued to prove their worth. In January, Dorothy visited his workshop with remarkable news. The Army's after-action analysis had attempted to calculate the rifle's impact on casualty rates. The numbers were necessarily approximate, based on comparing unit performance before and after receiving the new rifles and accounting for multiple variables. But the analysts estimated that Samuel's design had contributed to preventing approximately 3,000 American casualties that likely would have occurred with standard-issue weapons. 3,000, Samuel repeated, the number almost incomprehensible. Dorothy, that can't be accurate. There are too many variables, too many factors in combat. Dorothy sat across from him, her expression serious. The analysts were conservative in their methodology. They only counted clear cases where the rifle's superior accuracy or reliability made a documented difference. The real number is probably higher, but they can't prove it. Even if they're 50% wrong, that's still 1,500 lives. Samuel sat quietly, absorbing the magnitude of what she was saying. 1,500 to 3,000 people who would go home, who would have children, who would build lives. The number was so large it became abstract, impossible to fully comprehend. As the war in Europe ended in May 1945 and the Pacific War concluded in August, the demand for rifles naturally decreased. Production was scaled back, though not eliminated. Samuel's design had proven successful enough that it would remain in service, at least for specialized units requiring enhanced accuracy. In September 1945, Captain Collins, now a major, visited Samuel's workshop one final time before his discharge from service. The young officer who had first shown genuine interest in Samuel's work had matured considerably. The war had marked him, as it had marked so many, but he remained optimistic. "Mr. Hendricks, I wanted to thank you personally before I returned to civilian life. Your rifle kept me and my men alive more than once." The major paused, then continued. "I'm going back to school, studying mechanical engineering. I want to work on designs that solve problems the way yours did. Practical innovation that makes a real difference." Samuel shook his hand warmly. "You'll do well, Major. You already understand the most important thing, listening to people who actually use what you're designing." After Collins left, Samuel returned to his workbench. The workshop was quiet, except for the familiar sounds of his work. The rasp of a file, the tick of cooling metal, the small noises that had been the soundtrack of his adult life. But the silence felt different now, less like isolation, and more like peace. Margaret found him there that evening, as autumn darkness fell early over Springfield. She had news of her own. A job offer from a company developing early computing machines. The work would take her to California, far from home, but it was an opportunity she couldn't refuse. "I'm proud of you," Samuel said simply. "Your mother would be too. Dad, you should visit once I'm settled. California has beautiful weather, and you could use a break from New England winters." Samuel smiled. "Maybe I will. I'm not as rooted here as I thought I was." The post-war years brought changes to Samuel's life and work. His reputation from the rifle design led to consulting opportunities with firearms manufacturers who valued his expertise. He traveled occasionally, more than he had in his entire previous life, sharing knowledge and learning from others in ways that would have been impossible in his isolated workshop. Dorothy Williams continued working at Springfield Armory, eventually becoming chief engineer for small arms development. She and Samuel maintained a professional friendship, occasionally collaborating on projects. She married in 1947, and Samuel attended the wedding, pleased to see her happiness. The workshop remained Samuel's center, but it was no longer his prison. He took on apprentices, something he had resisted for years, teaching young men and women the craft of gunsmithing. The students who succeeded understood that they were learning more than techniques. They were learning a way of thinking about problems, about quality, about the relationship between maker and made. In 1950, Samuel received an invitation to speak at West Point about practical innovation and the importance of field feedback in weapons design. He almost declined, uncomfortable with the academic setting, but Margaret encouraged him to accept. The lecture was well received, though Samuel felt awkward throughout. What struck him most was the questions from cadets, their eagerness to understand not just the technical aspects, but the human story behind the rifle's development. One cadet, whose father had carried Samuel's rifle in the Pacific, asked, "Sir, when you were being rejected and dismissed, what kept you going?" Samuel considered the question carefully. Stubbornness, partly, but mostly the conviction that I was right about the design's potential. That's not arrogance, it's the result of really understanding your craft. When you know something deeply through years of hands-on experience, you develop an intuition that's hard to explain but reliable. The challenge is communicating that intuition to others who don't share your experience. The years passed. Samuel aged, his hands eventually developing the arthritis that plagues all craftsmen who work with metal and cold. He trained his apprentices to take over more of the physical work while he focused on design and consultation. The workshop became a training ground where tradition and innovation merged, where young people learned that the future didn't require abandoning the wisdom of the past. Letters still arrived occasionally from veterans who had carried his rifle. Some were brief thank you notes, others were longer, sharing stories of battles and survival, often written many years after the events they described. Samuel kept them all, a tangible reminder that his work had mattered beyond technical specifications and production numbers. In 1963, on the 20th anniversary of his rifle's first combat use, Samuel received a letter from a veteran named James Bradley. Bradley had been 19 in 1943, a Marine private on Guadalcanal. He wrote about a specific moment. Pinned down by enemy fire, he had made a shot at nearly 400 yards that eliminated a machine gun position, allowing his unit to advance. The shot had been possible only because of the rifle's accuracy, but the letter's real purpose was to share what happened after the war. Bradley had become a teacher, married, had 4 children, and now several grandchildren. He included a photograph, 3 generations of family at a barbecue, smiling in suburban sunshine. "This exists because of you," Bradley wrote. "Everything in this picture, all these lives and futures, might not have happened if that shot had missed. Thank you doesn't seem adequate, but it's all I have." Samuel placed the photograph on his workbench, where it remained for the rest of his life. When apprentices asked about it, he would tell them the story, not to brag, but to remind them that quality matters. That precision isn't just a technical value, but a moral one. That the work of their hands could ripple out into the world in ways they might never fully know. Margaret visited regularly, bringing her own children to meet their grandfather. Samuel taught them to shoot, starting with 22 rifles and careful instruction in safety and respect for firearms. He wanted them to understand that weapons were tools, serious things that demanded serious handling, but also that skill and knowledge removed much of the danger. His grandson Michael showed particular aptitude. At 12, he could already group shots tighter than many adults. Samuel watched the boy shoot one afternoon, noting his natural feel for the rifle's balance, his instinctive understanding of breathing and trigger control. "Grandpa," Michael asked after a particularly good string of shots, "did you always want to make guns?" Samuel thought back to his own childhood, learning from his father in this same workshop. "Not always. When I was young, I wanted to be a teacher. But my father needed help in the shop, and I discovered I was good at this work. Eventually, I realized that craftsmanship is a kind of teaching. Every rifle carries lessons in it about precision and care and taking responsibility for quality." By the 1970s, Samuel's rifle had been largely replaced in military service by newer designs. Evolution continued, as it always does, but his innovations had been incorporated into subsequent generations of firearms. The free-floating barrel design, the refined gas system, the sealed trigger mechanism, all had become standard features in precision rifles. His contribution lived on in ways that transcended any single weapon. Samuel passed away in 1978, at the age of 83, in his workshop. He had spent the morning working on a rifle restoration, had sat down to rest, and simply didn't wake up. Margaret found him there that evening, peaceful in the space that had defined his life. The funeral was attended by an unexpectedly large crowd. Former apprentices came, now master craftsmen themselves. Dorothy Williams attended, retired but still sharp, sharing stories of their collaboration with anyone who would listen. Veterans came, some traveling considerable distances. Men in their 50s and 60s who had carried Samuel's rifle in combat decades earlier. But the most moving moment came from a group of younger people, men and women in their 20s and 30s. They approached Margaret after the service, explaining that they were the children of veterans who had been saved by Samuel's rifle. Their fathers or uncles had told them stories about the weapon's accuracy and reliability, about how it had kept them alive to come home and start families. One young woman, perhaps 25, said to Margaret, "My father died last year, but before he passed, he made me promise something. If Samuel Hendricks ever died, I was to attend his funeral and tell his family thank you. He said he owed his entire life to that rifle, which means I owe my life to your father. How do you thank someone for existing?" Margaret had no answer, but she understood. Her father's legacy wasn't just technical innovation or even the medal for merit gathering dust in a drawer at home. His legacy was life itself, continuing and multiplying, spreading out into the world in ways that could never be fully traced or quantified. The workshop was eventually converted into a small museum, maintained by Samuel's former apprentices and supported by donations from veterans' organizations. The original test rifle was displayed there, along with his tools, his letters and photographs documenting his work. School groups visited, learning about innovation, perseverance, and the importance of expertise. Michael, Samuel's grandson, eventually took over the family business, though by then it had evolved into consulting and custom restoration rather than regular production. He kept his grandfather's workbench exactly as it had been, occasionally sitting there when facing difficult problems, finding that the space itself seemed to clarify his thinking. Years after Samuel's death, the military conducted a comprehensive historical analysis of weapons development during World War II. The section on Samuel's rifle was detailed, documenting not just the technical specifications, but the human story, the initial rejection, the persistence, the collaboration between craftsman and engineer, and the ultimate impact on combat effectiveness and casualty reduction. The analysis concluded with an observation that Samuel would have appreciated. The Hendricks rifle demonstrates that innovation often comes from unexpected sources, and that institutional resistance to unconventional approaches can delay critical improvements. The successful development of this weapon required both individual expertise and collaborative adaptation, suggesting that optimal outcomes emerge when traditional knowledge and modern manufacturing capabilities are effectively integrated. The rifle's estimated impact on casualty prevention was updated using more sophisticated analytical methods and access to more complete records. The new analysis suggested that Samuel's design had contributed to preventing between 2,800 and 3,200 American casualties across all theaters of operation. The range of uncertainty was smaller, the methodology more rigorous, but the fundamental conclusion remained: Samuel's rifle had saved thousands of lives. Margaret kept the letter from James Bradley, the one with the family photograph, until her own death in 2004. In her will, she donated it to the museum along with her father's Medal for Merit and his personal papers. She wanted people to understand that abstract numbers, 3,000 casualties prevented, represented real people, real families, real futures that had been preserved. The museum displays the photograph prominently, 3 generations smiling in suburban sunshine. The caption reads simply, "One of 3,000 reasons why quality matters." You visitors often pause there, studying the faces, connecting the abstract achievement of designing a better rifle to the concrete reality of lives saved and continued. Samuel's story became a case study in engineering schools, not just for the technical innovations, but for the lessons about persistence, collaboration, and the importance of listening to expertise, even when it comes from unconventional sources. Dorothy Williams, before her death in 1995, gave several lectures about their collaboration, emphasizing how much she had learned from Samuel's practical knowledge and how essential his insights had been to successful implementation. The rifles themselves, those that survive in museums and private collections, are recognized as significant artifacts. Collectors value them not just as historical objects, but as examples of successful problem-solving, evidence that individual expertise and innovation can make measurable differences even within large institutional structures. But perhaps Samuel's most lasting legacy is less tangible. The apprentices he trained went on to train others, creating a lineage of craftspeople who understood that quality was never just about technical specifications. It was about taking responsibility for the consequences of your work, about understanding that the things you make go out into the world and affect real people in real ways. Michael, working in his grandfather's workshop decades after Samuel's death, sometimes pauses in his work and thinks about that legacy. He remembers Samuel's hands, scarred and strong, shaping metal with patient precision. He remembers the lesson his grandfather tried to teach through everything he did, that craftsmanship is ultimately about human connection, about making things that serve people well, that keep them safe, that help them accomplish what they need to accomplish. On quiet evenings, when the workshop is still and the only sound is the settling of old wood and the distant hum of traffic, Michael sometimes feels his grandfather's presence. Not in any mystical sense, but in the accumulated knowledge embedded in the space itself. Every tool carries the memory of how Samuel used it. Every technique passes down insights learned through decades of practice. The workshop is not just a physical place, but a repository of understanding about how to work metal, how to solve problems, how to maintain standards even when easier compromises are available. And somewhere in the world, scattered across continents and decades, are the descendants of the soldiers whose lives were saved by Samuel's rifle. They go about their daily existence, working, raising families, pursuing dreams, unaware that their very existence can be traced back to a stubborn gunsmith in Massachusetts who refused to accept rejection, who believed in his craft enough to persist when others dismissed him as irrelevant. 3,000 casualties prevented. 3,000 soldiers who came home. How many children did they have? How many grandchildren and great-grandchildren? The numbers multiply across generations, cascading forward in time. Samuel never knew most of these people, never met the vast majority of the soldiers who carried his rifle. But his work lives on in them, in their descendants, in the accumulated impact of quality and precision, and refusing to compromise on things that matter. The rain that hammered against Samuel's workshop windows that November day in 1942, when Captain Morrison first delivered the rejection, has long since evaporated into air and sky. But the rifle that took shape in that workshop, refined through collaboration and manufactured by thousands of hands, continues to echo through time. Not the physical object, most of those have long since worn out or been retired, but the ideas it embodied, the lessons it taught, the lives it preserved. In the end, Samuel Hendricks was right about his rifle. Not because he was a genius, though his innovations were brilliant. Not because he was stubborn, though his persistence was essential. He was right because he understood his craft deeply enough to know what was possible, and he cared enough about the consequences to fight for that possibility even when everyone dismissed him. The workshop in Springfield stands quiet now, a museum rather than an active workspace. But the lessons learned there continue to ripple outward, through students and apprentices, through engineering case studies, through the continued existence of people whose lives were preserved by quality craftsmanship and precision engineering. The story of a man, a rifle, and 3,000 reasons why expertise matters, why innovation requires persistence, and why the work of our hands can echo through generations in ways we never fully anticipate or understand.